Now another side benefit is that we are integrating, of course, with Cube Voyager. I mentioned it was basically a TP plus travel demand model in the past used here. And this is really, one of the excuses for doing this is to upgrade the travel demand model to Cube Voyager. Turns out to be a fairly quick process to do that. And at the same time, also make sure that we're integrating the D's post-processor, or D's processor, I should say. It's not really post. It could be integrated with feedback. But the D's processor, for those of you who've been using this in California or other areas, is a methodology for assessing how changes in development might affect all the various parameters of a travel demand model, and incrementally modifying the trip tables used in assignment to reflect those changes. And what we find is that CubeLand can provide inputs directly to the Ds that enhance the overall process. So in the end, this model system that we're putting together here in this pilot study is going to integrate Cube Voyager, CubeLand, UPlan, and the Ds processor all into one integrated system that runs with just a single click from our scenario management interface. So this is a case study, again, still in the formative stages. I can't really say a whole lot about it at the current time. If we have time later on and you want to get into the details, I have some slides on sort of the data assessment, how UPlan data elements are integrated in. Might be different in some situations depending upon whether you're using UPlan or not. We know that there are other areas using UPlan that are interested in this kind of integration, perhaps, so you can contact me if you have more questions about that, or contact Troy Hightower as well, and he can tell you a little bit about what's been working on there. And that concludes this portion of our presentation. Since I'm about 15 minutes over an hour in, I'm going to stop here and give time to go through questions. I'll go through the questions typed into the question pane first, and then we will see if there are some questions or some people who want to actually speak via their microphone. So if you would like to actually ask a question using your microphone or telephone, raise your hand using the hand-raising button, and I will unmute you so that you can speak. But first, I'll go through the questions. Daryl Howard asks, what are the data requirements needed to execute CubeLand, i.e. how data hungry is it? I think I answered that through my slide about the data requirements. So let me just go back here to show you that we need some kind of information about real estate categories or real estate supply categories. We need some kind of information about the zones, some kind of information about the types of agents or households and jobs in the region. And basically what kind of information you supply here depends upon what turns out to be statistically significant during your model development and estimation process. So rather than having the software drive the data requirements for your land use modeling process, I think it'd be fair to say that with CubeLand, we let the process of actually analyzing land use drive the software requirements. So the software is actually responding to your needs, not the other way around. And as a result, it's probably one of the least data-hungry models, if not the least data-hungry model out there on the market. Would you agree with that, Francisco, Dr. Martinez?
Probably, because the more detail you go into microsimulation, you need more data to feed in for all the rules and details you want to model. So actually, the answer can be complemented by saying that you can define the level of aggregations with regard to your availability of data or the amount of data you want to, the effort on getting data you want to spend on. So in that sense, because it can be aggregated to different levels on spatial and demography description of the population, you can, and also on the firms, on the industry, you can actually control to that extent the amount of data you need to run the model.
Thank you. The same asker had another question. Are you aware of anyone that has used CubeLand outputs to inform more detailed indicator models such as Criterion's Index, which is parcel-based? I will say that I don't think that we've really done a lot with that yet. However, I know, well, personally, I'm interested in looking at the iPlaces effort, which is, I think, kind of similar to that in California, which is, again, an indicator model, which is sort of more about evaluating the land use pattern at this parcel-based level, less about actually modeling land use. But iPlaces is not really actually a land use model. It's more about, a sort of quick performance evaluation. And since, in the Central Valley they're doing things with iPlaces anyways, I think it would be interesting to take a look at something like the Kern pilot model and see what we can do to integrate and disaggregate the results so that we could use iPlaces with it. So in principle, I don't see any reason why this couldn't be done. Dr. Martinez, do you have any comment on that?
Can you repeat the question because I don't see it on my screen?
Sorry, yeah. The question is whether cubeland outputs have been used to inform more detailed indicator models that are parcel-based.
Indicators models.
Yeah, the idea being, some sort of parcel-based evaluation of land use in terms of various kinds of indicators or performance measures. Have you done any kind of work like that in Santiago at the parcel level?
No, we haven't. We haven't done anything at the parcel level so far. We have doing some discussion and research, basic research on how to do that, but not yet very far. The idea would be that once you have the cubeland outputs assessing the zone level by type of land use, like residential, non-residential, and by dwelling types and so on. Once you have at that level of aggregation, then you can probably do a good interpolation or more deep analysis into the performance of each of more disaggregated clusters, like specific parcels within the zone. So our view would be a sort of hierarchical process where cubeland has an upper level and a lower level analysis would provide information on at the parcel level.
I think it's kind of
why we see.
It's like this slide basically, isn't it?
Yes, sort of, yes. The idea would be that once you have at the cubeland level, the more aggregate, you have the economics correctly forecast. And then you go to the details within more specific issues like parcel level building types within the zone. Mm. So our view is that you have to make a good estimation of zone level, at the more aggregate level, of the economics of the system, all the interactions involved, and then try to assess more detail.
I have a follow-up question, actually, of my own, which is, I know we've discussed this in the past, but is there any, theoretically, would it be possible to apply cubeland using parcels as the zones? Is there anything, preventing us from developing a cubeland model that works in that way? Not really, is my...
Not theoretically.
Yeah.
Not theoretically. There is some difficulties to overcome. Theoretically it's possible, but difficulties are, for instance, how you represent the neighborhood at a parcel level. What is the neighborhood of a parcel? You will have to provide a definition of, for each parcel, the definition of their zone or neighborhood. That's something which comes directly by the zone definition. Once you don't have a zone level definition, you have to define a neighborhood for each parcel. Because there are so much interaction between the agents in cubeland, like neighborhood quality and so on, this affects very much the results. So this is an issue that has to be done with some work to verify that it's working correctly. The other thing is that the question of to what extent the equilibrium process of the market with regard to rents can be stabilized to a very detailed level of the variety of parcels. So if you introduce at each parcel a number of characteristics that describe the specific parcel, then you will have a more complex equilibrium process. So the idea in Cubeland is that you produce this equilibrium at the level of the dominant effects. So you synthesize most of the information at certain level. Once you go to a detail, the parcel, there's so many interacting agencies making contributions to the equilibrium, which makes it probably more difficult to actually find and attain the equilibrium. But theoretically, going back to the original question, theoretically it is possible. It's not only a matter of time consuming or running the model, but it's also a question of how do you specify the model for attaining the equilibrium.
Right. Obviously, the specification would be very different depending upon the level of geography, and I think that applies to also increasing the scale. If you were to use Cubeland at let's say a statewide level or a nationwide level, and you're actually allocating households and firms or jobs to, let's say, census tracts, zip codes, or even counties, the functions would look very different than they would at a more sort of regional scale with traffic analysis zones, correct?
Yeah, it is correct, but let me say what means different in this case. Once you go up to more aggregate levels, as you mentioned, what is basically changing, what matters for the consumers to decide where to live or where to locate their firms. So the attributes, the characteristic that matters, that attracts them to counties, cities, or whatever, would be dependent on the level, the geography level. For example, if you are talking about a model applying Cubeland to a census tract as compared to a city level system of cities, the level of details that attract people to each of these geography levels is totally different. You decide a city for a very long-term location of activities, where you, at the census tract, you probably are more movable, and the details are of what you are considering as attractors are totally different. Mm. But essentially, it's the same problem that you have to decide based on, say, 5 to 10 to 20 attributes. What is relevant for the consumers to allocate somewhere their activities. So essentially, it's the same structure, but what goes as input to the model to represent consumers' behavior is different.
Mm. Okay. Do you have any other?
Also, the constraints are different. It's important to mention the constraints.
Mm.
These spatial systems are normally very much regulated by a number of how do you call regulations, planning regulations?
Yeah, zoning. Mm-hmm.
Yeah. All these means that not everything is allowed everywhere, and therefore you have to put that into somewhere in the model. And the Cubeland allows you to replicate all these regulation or zoning as constraints to consumers and suppliers. What is a regulation it's also relevant related to the geography level you are considering, and therefore what regulations apply and how also matters with regard to what level of geography you are applying the model.